Hi there, and welcome to today's class. We're going to study of halo effect in physics. So let's discuss the idea behind halo effect. By definition, halo effect is the production of a voltage difference across an electric conductor transverse to an applied mechanical field perpendicular to the current. Halo effect enables us to determine the sign of the charge carrier. It is the product of the potential difference across a conductor carrying current in the presence of a magnetic field. That's how you define halo effect by definition. Let's look at the formula for halo effect. So I won't give you the formula, rather I'll try to prove the formula derivation. So from experiment, put on please. From experiment, the electric force is equal to magnetic field. From experiment, we are saying that electric force is equal to what there? Magnetic field. By the way, electric force is represented by Fe, which is equal to magnetic force there uses Fm. All right. So I have Fe, which signifies electric force, and I have Fm, which signifies magnetic field. So when it comes to halo effect, the idea there is that from experiments that is discovered that electric force is equal to magnetic field. This one is true. First things first, what is electric force? From this man here, Fe is equal to QE, and also Fm is equal to QVB. These are the expression for electric force and electric field. If these two men are the same, definitely I'll have to equate the equations. So I'll have we said EF, so Fe equal to Fm. What's Fe? That's QE. So I have QE equal to Fm, and of course Fm is QVB. So I have QVB. At this point here, I'll divide through by Q. Correct. So divide through by Q. By Q, what do you get there? I'll have QE. This gives you QE over Q equal to this one here gives you QVB over Q. This one gives you Q cancel Q. I have Q cancel this Q here. I have E equal to VB. Alright, call this man here. Call it equation 1. Call this man equation 1. So from here, I try to equate these two expressions here. And at the end of the day, I have an expression E equal to VB. Call this one here equation 1. From this part here, let's make V subject. So make V subject. Make V subject a formula. From here, I'll divide both sides by B. So I have E over B equal to VB over B. This man will cancel this here. I have that V, therefore, V is equal to EB. So I have E over B. Call this one here, call it equation 2. So I have call this one here equation 2. Alright. What next here? The next task here is to apply the idea of halo voltage. Alright. From here, the halo voltage, that's in bracket VH. So VH is just for representing halo voltage, right? So it's given by VH equal to ED. Alright. This is formula for halo voltage, right? So after passing this process, and get equation 1 and equation 2. Next task is to recall your Halo voltage formula. This gives you VH equal to ED. At this junction here, I can see E, I can see D. Of course, E, this E you are seeing, the value is dB. So it's easy as before then, okay, proceeding from here. Before then, we said this E, but we said this capital E is equal to what there? VB. I have VB. Anywhere I see E, I'll put VB. So I have VH equal to E is VB. So in brackets, VB. Then I have D. All right, I have D. From here, I'll multiply through. I'll have that VH, which is signifies the halo voltage, right? So this gives you VH equal to, this gives you VBD. All right, this formula here is formula for halo voltage. That's V times B times D. What's V? What's V? What's V? Let's try to get what this man mean and proceed. So let's try to get what it means. All right. From here, where V, perhaps VH 12 or V means velocity of the moving electron. All right. Next up I have B there. B signifies the magnetic field intensity in the Tesla. All right. All right. That's by the way. And D there signifies the weight. This D, so D, this one here, D signifies the weight. All right. Of all right, strip. So I have these parameters well defined. So for halo voltage, that's VH, is given by VBD, where V signifies velocity of the moving electron, B signifies magnetic field intensity in this Tesla, and this signifies the width. All right. From here, please. From here, put on please. At this junction, note. Right. At this point here, note one key important concept. At this point here, let's note one key important concept. Note the current can be expressed in terms of draft velocity in bracket V. I said the current can be expressed in terms of drift velocity in bracket V. Next task, area in bracket A, and number of charge per unit volume in bracket M. I said the current can be expressed in terms of drift velocity in bracket V, area in bracket A, and number of charge per unit volume in bracket N. All right, so it means that is from here I can say that I is equal to Q N A V. I'll call this one here equation 4. All right, I'm trying to bring in the concept of current, that's I. So the first one, equation 4, what do we know? I'll make V subject here. So make V subject. Making this, I'll have that V is equal to I all over QNA. All right, I have this. Call this equation 5. Equation 5. Next task now, I'll put 5 into put 5 into this equation. Let's call this equation asterisk, right? So put 5 into equation asterisk. This equation here. From here we have that VH is equal to V. Now observe please. V. What's V? V is this. VD. So I have V. What's V? V gives you I over QNA dot BD. I have BD. Alright. From here, I have that VH is equal to, multiply this, I have IBD all over what then? QNA. In applying this concept in normal formula, this is still the formula for halo voltage, right? But here's the idea. The real formula becomes VH is equal to, this is still correct but not proper. This gives you V is equal to 1 over NQ. Bring that NQ this way. I'll have IBDA left in bracket here. IBD, IBD, then I have A this way down. So this is how you express halo voltage formula as this place. So this is how halo effect works. This is formula for the halo voltage, right? So from here, what does it? 1 over NQ has a definition. So what does it mean? So 1 over NQ, what does it mean? From here, 1 over NQ actually means that's halo coefficient. Halo coefficient, that's the meaning. Next up, I have V. V means drift velocity. Next up, V means the magnetic field. Magnetic field. That's D means the width. The width of strip. So please identify each definition for parameters. So I'll define I. Okay, 1 over Q, 1 over NQ. I'll define V. I'll define B. Okay, BD. All right. What of A? A means area. Area. I can get area by what? By multiplying the depth or the width by the thickness. That's H. Thickness. By the thickness. All right. That's H. So I can get area by multiplying D and H together, as easy as that. Please note that Q is equal to 1.6 times 10 to the power minus 19 coulomb, and I signifies current. All right, in ampere. This is the formula for the concept of halo effect. So this is how this man works. So let's use this idea to solve some problems and see how we can get some concept with this. So let's do a past question on this concept. Welcome back. Let's take some examples under halo effect, or perhaps under the study of halo effect. It says, in a halo effect experiment, a current of 3.0 meter ampere lengthwise in a conductor 1.0 centimeter wide, 40 cm long, and 10 micrometer thick, produce a transverse halo EMF of 10 microvolts when a magnetic field of 1.5 T passes perpendicular through a thick conductor. Find A, the drift velocity of the charge carrier. B, the number of charge carrier per unit volume. That's N. So let's get this done, please. So first things first, your first task in science is that after writing down the question, right, list out the parameters, right? First task there, solution. The given this is, it says, in a halo effect experiment, a current, so first task there, given current, that's I, current is I, the value that is given by 3 meters ampere, right? And by the way, this gives you 3 times 10 to the power minus 3. 10 to the power minus 3 signifies meters. Then I have ampere. Current is in ampere, not in meter ampere. Convert the meters. The meter there means 10 to the power minus 3. So I have this one here. Proceeding there, it says lengthwise in a conductor 1.0 meter wide. So I'm given D, that's the width. So D has the value there 1.0 cm, that's the width, right? Convert it to meters, this gives you 0.01 meters. All right, I have this in meters, that's the width given. Next task there says 40 cm long. 40 cm long is one length, so length is 40 cm. Convert this man to meters, this gives you 0.04 meters. All right, next task there, it says 10 micrometer thick, that's H. So H is given, H there is thick, that's 10 micrometer. Micro 10 to the power minus 6, this gives you 10 times 10 to the power minus 6 meter. All right, that's micro. That's the value of H here. Next task there, I'm given EMF. So that EMF there means electromotive force, and the EMF there is for the halo voltage. So in that case there, I'm given VH as being equal to 10 microvolts. We said micro here means 10 to the power minus 6. This gives you 10 times 10 to the power minus 6 volts. So I have this one here, that's H. I'm also given magnetic field, that's B. So B is given to be equal to, I have 1.5 meters T, and this is equal to B equal to 1.5 meters there means 10 to the power minus 3, I have T. So I have this as mine. I'm also given magnetic field. Similarly, I'm also given so we know that Q is constant. We know that Q is constant. That's 1.6 times 10 to the power minus 16, 19 coulomb. All right. So I have these parameters given. So next task here is that we have to find two things. The first one is called the drift velocity, that's V, and second is called the number of electron, that's N. Number of volume carrier, right? First, let's get V. Because it says find drift velocity in bracket V. How do you get V? So recall that from the formulas I gave you, you have that VH is equal to VBD. We have this expression there, VBD. So it's easier that we're trying to find V, this V. Am I given VH? Of course, VH is given, this is VH. Am I given B? Capital B, of course, is given here. D is given also, I have D here. So we can get V. easily. So let's make B subject here, divided by BD by BD. This mark cancel this here. I have that V from here. V equal to what there? VH over BD. Input parameters. This gives you V equal to what's VH there? VH here is this 10 times 10 to the power minus 16. Okay, minus 6. Sorry, minus 6. That's V. That's VH. V, of course, what's V? 1.5. 1.5 times 10 to the power minus 3 times what's D? D is 0.01. So we will see 0.01. So if I work on this, the value for VH will be equal to, if I punch everything here, VH there will give me about 0.66 meter per second, because it's the velocity. Sorry, not VH, please, it's V. I'm asked to find V. So V. So I have that V is this value. So velocity is in meter per second. So I have 0.066 meter per second as the value for the velocity we have to find. That's drift velocity. Last part says to find the number of charge carrier per unit volume. That's N. So let's get N. Alright, let's get N. Okay, let's get N. So let's get N. We have to find N for B. We have to find N. We are asked to find N for B. What do we do? First, we know that recall that we established that I is equal to QNAV. Right, QNAV. We established that the current. We establish this fact when we're deriving formulas for Halo effect, that Q times N times A times V gives you current. In this case here, I'm asked to find N. It's possible for me to find N using this equation. Why? Because I have I. This is I have Q is a constant. I have A. What's A there? Now we said A can be got by multiplying your thickness by what there? By your width. Alright. V is, we said V, just got V, value of V recently now. We got V should be about 0.006, 0.66, that's V. So let's make N subject here. To make N subject, making N, I have N is equal to I over QAV. Let's get A first, because we said we want to find A. And area, the area here gives you breadth times what? Height, the thickness. This gives you what's the breadth? B. So I'm multiplying this D with H, per se H. Correct. Sorry, this is D. It will be D, not B, please. So D times H. D gives you 0.01. So I have 0.01 times H here. H gives you this value. That's 10 times 10 to the power minus 6. Multiply this together. I'll have that A is equal to 1.0 times 10 to the power of minus 7 meters squared. That's value of A. So I've gotten A. I can easily get N now. How? Substitute. This gives you N is equal to. Alright, so let me take this off. Take this off. From there, we have that N is equal to I. What's I? Let me get the value. I is 3 times 10 to the power minus 3 all over what's Q is constant. That's this value here. That's 1.6 times 10 to the power minus 19 times what's A? A is ignore your area. I'll just get the value as this one here. That's 1.0 times 10 to the power of minus 7 times what's V? And that's the value we got last. That's V, that's 0.66. We got this expression. Multiply through n should be equal to, if I punch everything here, this should give me about 2.8 times 10 to the power of 23. Alright, this becomes my final answer to this particular question. In quote, it says the number of charge. So number of something do not have SI unit, right? That's right there. So in this case now, I have no unit here. So this is value of n. So n, perhaps this man could still have unit because it's saying the number of charge carrier per unit volume, and volume there should be in meter cube. If this one is meter square, I should have a meter cube here in that case. So I should attach a meter cube here because volume is in cube. So I have meter cube. This becomes your value to this particular question. This is a solved problem under halo effect. If you find this class helpful, don't forget to like the video, share to your friends and classmates, and subscribe to my YouTube channel. See you guys in our next content. Also, if any topic interests you, you can send us a comment section that you want a topic we should discuss in the next class. So if you found this class helpful, once again, share the video, like, and leave a comment. See you guys in our next class.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. I just launched my website www.ghanabukari.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys, and welcome to my channel. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM students, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine, which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right. So once you join the channel membership for other level student, you will have access to both the YX and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.